Hello, my name is Andrei and I'm going to give you a short introduction on TDMS, which is ISA's software for controlling the test equipment. TDMS is short for, as you can see, Test and Data Management Software. And in this part, the good thing about TDMS is, first of all, it is complimentary, so you don't have to pay for it. And second of all, it is used to control all ISA test sets. So using this one software package, you can control many test sets, some of them being test sets for relay testing, circuit breaker testing. This would be, for example, relay testing. This would be circuit breaker testing. This would be energy meter and transducer testing, including the power quality meter testing. And this would be the transformer testing application. This is the testing of batteries. And this would be so-called programs control tab, as you can see here. But there is also a network tree. And the network tree is, in short, a big database of all the tests you have done for yourself. So here you can create a database for your network, and then inside of a network you can create substations. Inside of a substation you can create lines, and inside of lines you decide what you want to test. So in this case we were testing only breakers, where in this case, let's see, we were testing also breakers. This is the network tree. And about program control, I'm going to show you here some of the basic applications. So the first one would be manual control, and manual control is basically a generic application which allows the user to generate any currents and any voltages from any output of the RTS. Each output output is autonomous, so it can be set regardless to other outputs when it comes to amplitude, phase, and frequency. So you can see here we have statuses pre-fault and the status fault. In the fault status, the types of tests you can do can be a shot, delta ramp or a ramp, or dragging. And if you have a question, what is what, you can always press this question mark, which will show you then what is what. So this would be a shot, sudden change of state, or you can have a delta, which can be used in order to get, for example, the whole characteristic of an overcurrent relay, or you can have a delta ramp, which would allow you to test the threshold. Of course, you can use the ramp, which is also very useful, or dragging, which allows you to change the output using a certain, basically like a potentiometer. You can change it in real time. So these were the modes of generation. Also, shot types can be pre-fault, fault, pre-fault, fault, pre-fault, fault, pre-fault 0, and fault 0. You can here generate DC for the supply of your relay or transducer which you're testing, or power quality meter. And here you can change the phases. You can also change the phases in a ramp, or in a shot, or in delta. So this would be the manual control. Also, you can see here that you can see the values in phase to ground or phase to phase values, or you can generate different symmetrical components, or different power values, or impedance values. So to be practical, if we want to have, let's say, 5 amps, I press this button in order to make all three currents 5. And then here, if I have 57.735.735, you can see that right now I have a symmetrical system. And if I press line to line, this will give us 100 volts phase to phase. And in symmetrical components, we can see that we also have only a direct component. If by any chance I want to add some inverse component, for example 10 volts, then we can see in phase to phase, phase to line values how, for example, the amplitude and the phase shift change in order to accommodate the negative component which we set up here. The results in general can be seen here. It can be a graph or just a simple table form. So this would be our manual control, and we will continue with the sequencer.